Hello, everyone, and welcome back. This is Professor Theory, continuing our discussion of the conditionals. So last time we have seen some of the conditionals in addition to the simple version of it. It's just an if statement. We saw if else, and we have seen if, elif, right? So a couple of different structures you could have in order to bring about how to make a choice if you have several choices there using if. So we're going to continue our discussion of that today. Let me just go ahead and share my screen. And we'll start with the multiple alternatives today. And we'll also talk about the nested structures. So multiple alternatives is very similar to what we have just seen. And so originally we saw just the very simple if statements that had if, and then we decided to say, okay, well, what would you do if you wanted to say, else? So we had if and else, which would have one conditional and then one alternative being that else. But what if you wanted to test several conditions and also have an alternative, that else, to collect all the other choices? So that's where the multiple alternative structure comes up. It's sort of like the else serves the purpose of like the none of the above. When you have a multiple choice question, sometimes you just need something that doesn't really fit anything that we've already seen. And so when you have if and then you have several elifs chained to that to give some alternatives, then the thing is that we might want to say, okay, so what if none of these apply? When something is to be done contingent upon some condition, and if the contingency is not met, we would check if other contingencies are met. That's where the elifs come in. So we've already seen that. Again, we could use the Boolean type to decide, so we'd have the branch guards just as we've seen before. We could have multiple elif clauses to form multiple branches, which we have also already seen. And then we would put an else clause at the bottom to catch whatever does not meet any of the prior conditions. It's a sort of like a catch-all for anything that hasn't already been caught. Execution operates similar to the examples we've seen before. That is, the first branch evaluating to true will execute and no other branches will execute. So we start at the top and we check to see, okay, does contingency A match? Does contingency B match? And you go down each of these until you find one that's true. But what if you get to the bottom and none of them has been true? That's what this else will catch. So in the previous situation, we had if, elif, right? But it's possible that none of those conditions are met, and so then no action would be taken. But this guarantees that at least one branch will execute because you could capture it in the else. Just like before, if multiple branches are true, the first one, which is true, will execute. So you cannot execute any other true branches if any exist. Python won't even test once it finds a true one. So it's very similar to what we have seen before. Let's see what the syntax would look like. Multiple alternatives has an if and then a Boolean expression. These are the branch guards, just like we have seen before. Then we would have our first conditional statement and so on. So this is the branch, which is the body of the if statement. Then we would have elif, again with its own Boolean expression to set some condition that we want to test. And we would go through here and test all of these out. And then we will continue on and on, just like so, to see if any of these is true. Then we get down to else. So just like before, else does not take a Boolean expression because it means all of these have been false, then this one will execute. So we don't need to provide another expression. So that's why there's no Boolean expression after it. It just means none of the others have been met. So there's no branch guard. And then we have all of the conditional statements to execute. It's kind of like default. So let's take a look. Here's a multiple alternatives example. This is very similar to the one we took a look at last time. So suppose x is equal to 5. Now do you see that x being 5 will make this be true, x is greater than 3, true, and 1, right? So all of these are going to in fact be true. And then we have our else branch here with the default branch right here saying none of the above applies. But multiple of these could be true, which in this case would be the case. So if x were equal to 5, then what would happen? Well, this branch would evaluate to true, which excludes any of the others even being considered, and it would print x is greater than 3. And because they are blocked together, then it would not consider any other branches. So just print x is greater than 3 is the only thing that would actually execute. Now let's suppose that none of these were true. Let's suppose x equals 0. Is 0 greater than 3? No. Is 0 greater than 2? No. Is 0 greater than 1? No. Else. So you see that now we have come through all of these, and now we are at the else. We will print none of the above apply. So we're guaranteed to execute one branch. And if none of these are satisfied, it will go to the else. All right, so let's then discuss the nested conditionals. So why stop at one layer when you could have multiple layers? Sometimes more than one condition needs to be met in order to arrive at the final answer. Did you ever play that game, 20 questions? Where you can ask 20 questions, yes or no questions, and you have to try to guess something. So I might say, I'm thinking of something green, okay? And then you have to try to discern what that green thing is by asking me yes or no questions. You can see that somebody might ask, you know, is it inside the room, right? And if I say yes, then that's helpful because you know now you need to guess things inside the room, and you don't need to guess, you know, the trees outside or whatever. But you do need to ask another question before you're ready to guess what it is, because there's probably a lot of green things inside the room. So then you'd ask another one. But if I had said no, do you get the idea that then you would have wanted to ask questions about things outside? So we get this idea of nesting, that perhaps there could be some other ifs, some more conditionals inside of the first conditional. They're going in and they're branching out from each other. So more calculation may be required after one decision, but before another decision. We would use conditionals as part of the body of another condition. So you can start a whole new if block inside the body of another if. A nested if statement becomes one of the conditional statements of another if statement. The beginning of each if block must begin with if and not elif. Yeah, sometimes this gets a little bit confusing because students see that there's already an if, but it's not at the same indentation level, right? So that's the key thing there. So you can only do elif if it's connected to an if. Just like we said, it doesn't make any sense to have an elif if you don't have an if in just simpler situations. It's the same thing if the if block that you're inside of is outside of it, which it would have to be if it's inside of one. You can't do if and then indent and do elif to connect to that if. The if and the elif have to be at the same level. So anytime you're starting a new block, it always begins with an if statement, because you can't do something besides the other statement, if that makes sense. The beginning of each if block must begin with if and not elif. And why stop at nesting at 2 levels? You could go as deep as you would like. This is our syntax of the nested conditionals. And I'm giving you just one example because there are going to be many, many ways that you could do this. So again, we have if, elif, blah, blah, blah. You could have as many of these, and else you could have if and elif with no else. You could have if and else. You could have this in any combination, okay? The key thing for the nesting is this part right here. The if statement is inside the body of another branch. Do you see that this is the Boolean expression, right? It's the branch guard. And now we're inside this branch. And so we have begun a new if block right here with an if statement right here. And you can do the nested conditional of any type. You can do if and else, if, elif, else. You can do if, elif, and no else. Any combination in here is going to work just fine. The thing that makes it nested is because it is inside the branch. Once again, see how this one begins with if, and then this one also begins with if. This could have appeared in the elif branch. It could have appeared in the else branch. It doesn't really matter. And you can have more than one of these. You can have one here and you can have another one here. You can have one here and you could have a new if inside of this one, which would have you nested at 3 levels. So there's all different ways that this could work. Let's take a look at this. We can use nested conditionals to classify objects. This is a nice illustration. Maybe you had a toy, it's a kid's toy, you might remember it, where you have some blocks and you put them in the holes to put them inside of this other thing. We had one that was like, I don't know, a dodecahedron or something, and it has the holes and you put the little blocks in, right? And you say, okay, which geometric shape is this? I'm kind of thinking about this blocks game when I'm thinking about this. It's but let's do it as a classifying shapes game. So we have the blocks of these kind. Maybe there's a whole basket of these blocks and you're going to like pick one up, and the idea is decide which shape it is. So I might pick it up and ask you, you know, again, that 20 questions idea. You can ask questions about the block that I've just drawn and see if we can figure out which block it is, see if you can guess it. Okay, so we're going to think about binary questions for yes or no and to figure out, is it the cone, the cylinder, the cube, or the triangular prism? So some of the questions we might ask to classify these would be, does the shape have a circular face? Well, if the answer is yes, then it could still either be the cone or the cylinder, and we'll need to ask a certain question about that kind of block to distinguish between these two. But if it does not have a circular face, then it might be either these two. So then we will need to ask questions that distinguish between these. So for example, does the shape have an apex? That means the pointy part. Right, so this one doesn't have any points, this one does. So if the answer is yes, it's going to be the cone. And if the answer is no, it's going to be the cylinder. So then we want to see like which one of these it is. But this, notice that this question would not have been appropriate to use in this section because that would not have distinguished between the cube and the triangular prism because they both have quite a few apexes. So that wouldn't have really worked. So again, the question is going to depend upon the answer to the previous question. Does the shape have a circular face? Because this one will help you decide between these two. And then the answer was no. We might ask, knowing that it could be either of these two, does the shape have 8 vertices? And so then we would be able to tell apart between these two. So then if the answer is yes, we can conclude that we have the cube, and if the answer is no, we would be able to conclude it must be the triangular prism. So see that this little flowchart nicely illustrates binary decision making, but it also lends itself quite well to the idea of writing some code, and that's what we're gonna take a look at. Write a function, classify shape, containing nested if statements to classify the 4 geometric solids suggested by the diagram. These 4 down here we've just gone through. You could prompt the user with input with yes or no questions and return a string containing the name of the solid or undetermined if input was invalid. So let's see how we would write some code for that. Hold your hats, everybody. It's going to be pretty long. So here it is, nested solution. So I'm going to create a function called classify shape, This isn't going to take any input here because we are going to prompt the user with questions. Okay, so we're not going to take any input, and we're going to return the string that will say the name of the solid, or it will say undetermined if they didn't provide the correct answers. So I'm going to choose to call my variable y or n for yes or no to get the idea that we're going to get a binary answer. Either the user is going to type y or n. So here we're going to say y or n equals input. Does the shape have a circular face, y or n? So this is going to be reminiscent of this question right here. And we see that this is the outer if statement. So that's the first thing we need to ask. If they have responded y, then do you see that we know for sure we are on this side of the flowchart? We need to ask, does the shape have an apex? Which we now have right here. Input, does the shape have an apex? We're going to, I recycled the variable. You could use a new one here, but since I didn't need the outer one anymore, I just reused it so we don't have too many variables here. So the idea is they should type the letter y or the letter n. If y or n, oh, actually I did change it, y or n2, okay. So if the y or n2 equals y, then do you see that we have decided it is the cone? So we'll return the string cone. So either they, so first of all, we asked, does it have a circular face? And we got y. And so the first choice is, if they did, it's the cone, but then we need to say if y or n equals n, because that's the other alternative. So notice that this block is inside of this. These are all the cases for when they did say, yes, it has a circular face. But if it does not have an apex, the answer will be n. And so we know from that that it must be the cylinder block. Suppose your user typed something else. So here we are dealing with dummy proofing, right? Else is great for helping out with dealing with dummy proofing your code. That's not a valid y or n answer is what gets printed, and it will return undetermined. So here we've handled all the cases on the left-hand side. We've handled if they say yes, whether or not it has an apex. If it does, then it's the cone. If it does not, it will be the cylinder. And then if they type something else, it means it's not one of these blocks. Oops. And so now we need to deal with the other case. So this is very helpful in seeing a nice illustration of the various kinds of cases we talked about. You could have cases that you need to handle, right? You need to do exceptions. And so this, for example, would be an example of an exception. They typed something besides y or n. They didn't follow the instructions. And what are you going to do? You put this else here to deal with it. Okay, so, but they might have said n. Does the shape have a circular face? They might have said n. So now we know we're on the right-hand side of the chart. Y or n equals input. Does the shape have 8 vertices? Right, that was the next question we needed to ask. Does the shape have 8 vertices? If it does, it'll be the cube. If not, the triangular prism. So let's take a look. Does the shape have 8 vertices? Y or n? If they say y, we know it must be the cube. And then we have if y or n 2 equals n, then it must be the triangular prism. And again, we will handle that edge case with print that is not a valid y or n answer, and it will return undetermined. So we can get undetermined either way if they don't correctly answer the question. But now, don't forget, they could have typed something besides y or n in the initial question. So here we've handled the case that they said, yes, it has a circular face. They said, no, it doesn't have a circular face. But they might have typed, I don't know, z. Who knows what they could have typed. And then it says that's not a valid yes or no answer. And you'll get the undetermined here as well. So the key things to recognize code are that we have if, elif, and else is the outer if block. So here's this if block right here. And then we have indented if blocks inside of these. We have one inside each of these. There could be an if block inside else. We didn't need one for this. But this is what makes the if block be nested. because it's indented. And as you can see, there can be two nested ones in the same one, just one is in each of the bodies of each of these. So this is a really good one to review. It gives you a good sense of taking care of that flow control based on the question that's being asked. So you don't need to take my word for it that it actually works. Here I've illustrated the actual execution of this. And so we can see that I actually tried answering all the questions in all possible configurations, and we can get the cone, the cylinder, the cube, and the triangular prism. And this is a way you can get the undetermined. That's definitely not Y or N. So you can do that. All right, well then, I hope that this has been really helpful for you. We have now reviewed all of the conditionals with if statements. Just to go back to our bird's eye view, we took a look at input to begin with, another look at input, and we motivated our discussion by saying, well, what will happen if users don't put in the expected input? Or maybe you just need to make a choice, right? And we talked about dumbing proofing your code and the edge cases. We started off our discussion of the if blocks with just the simple if statements. We then looked at the alternative execution as if and else in it so that you could handle an alternative if the statement wasn't given there, that's binary. Then we looked at the chain conditions. So if, elif, chains together different conditions that could be made. We have also then today picked up with the multiple alternatives, which is very similar to the chain conditions, but instead of the alternative execution was just as if and else, you could have if, elif, and then finally an else, which makes it the multiple alternatives. And finally, we have taken a look at some examples where we have nested conditionals, that is, conditionals inside of the branch of another conditional. All right, well, this concludes our discussion of the if blocks. I hope that you found this helpful, and we look forward to meeting up with you in our next video. Hope you have a great day, and we'll talk to you soon.